Hi, my name is Hope Roderick, and this is part one of my Phonation Lab. I'm going to be identifying the 5 laryngeal landmarks and describing what I feel as I perform each step. So, first, we're going to find the thyroid notch, which is basically the Adam's apple, and if you can't tell, I have a big one right here. You can see it. Right there, sticks out pretty big. Okay, so this is my thyroid notch right here. It's in the center of my throat. I'm pushing my finger back at this point. It feels like a little notch or a dip. It sticks out the most on my neck. I have a big one, but yeah. Okay, next I'm gonna slide my finger upward to find the hyoid bone. Wait, okay, here's my thyroid notch. And I'm gonna slide up right there. Right there. That's, oh, I can feel it. Here's my, yeah. Oh, feels crazy. This is my hyoid bone. It's like a small, firm, it's really close to my Adam's apple. Firm structure just under my jawline. It's the only solid part in the area that's left up there. So yeah. Okay, now I'm going to slide back down to my thyroid notch, so from here to here, and slide my finger downward until I feel the circular ridge, which is the cricoid cartilage. So I'm gonna slide it down. Yeah, I can feel it right there. Oh, it feels crazy when I swallow. Anyway, it's a bit more rounded and firm. I'm trying to be careful not to go too low to hit the sternum, but I'm pretty sure this is it. Right here. Here's my thyroid notch, and here's my cricoid cartilage. There you go. Okay, so now I'm going to swallow while keeping my finger on the larynx, or the cricoid cartilage. Oh wow. When I swallow, hold on. I forgot how to swallow. Wait. Wow. Okay, so I can feel the entire thing lift up. It's like my finger's staying here, but the whole thing's going away from my finger. And then it comes back down. That's the larynx moving as I swallow. That's pretty cool. It feels crazy to do that. Okay, next I'm going to sing. I'm not a singer, but I'm going to sing while my finger's here. I'm going to try to do like low, medium, high. I don't know if I can do that, but I'm going to try. Okay. Wait. I'm going to do low first. Oh, wait. Sorry. Wait. Wow. Okay. As I change pitch, I can feel the cricoid cartilage shift slightly and the larynx as a whole move. The higher the pitch, I feel like the more it rises in my throat. And it's also vibrating more, I think. Wait. Oh. No, it vibrates kind of the same, actually. But the more high it is, the more it moves. Yeah. Anyway, that's part one of my Phonation Lab. Thank you. Hi, I'm Hope Roderick again, and I'm going to be doing part two of the Phonation Lab, or the Bernoulli Lab, part 2. So first, step 1, I'm going to make a tent. Straw and paper. I did measure and cut this paper. So it is 3 by 5 by 4 inches. I'm going to put it in a tent shape and place it on a flat surface like this. So, tent, first and foremost, tent. I have not tried this yet. So, we'll see if my predictions suck or not. Hopefully they don't. Here is my tent. Okay. cute little tent and a straw. So I'm going to predict my outcome now. So based on Bernoulli's principle, I predict that when I blow across the tent, okay, I don't think it's gonna like fall, but I think the sides might rise or move because of the fast moving air, which will lower the pressure. Okay, that's what I'm thinking. I'm going to blow 2 inches away, about like right here, I think. Like this. 2 inches. Probably right there. Should I use a ruler? I'm going to use a ruler. Do this right. 2 inches. I'm going to blow like this, and we're going to see. Okay. So it kind of was like trying to fold in on itself, but it didn't. It did move. I think I kind of got that right. I mean, I said that it will rise or shift significantly. Oh, slightly. I said rise or shift. I kind of went down. Maybe I was supposed to blow like this. I don't think so. I think I had it right the first time, like that. Over here. Okay, it's kind of moving like that. So, okay, so I blew a steady stream about 2 inches above the tent. So I observed that the sides of the tent kind of try to dip a little bit, but they weren't moving that much, I would say. I say it's because the fast moving air above lowered the air pressure, causing it to kind of push down on it a little bit, like that. Now I'm going to do a stronger blow. My prediction for this one would be, if I blow harder, I think it would go down more, obviously. I mean, I blew lightly and it kind of went down, so I'm thinking it's going to go down more. Maybe even like collapse on itself, maybe, due to the stronger Bernoulli effect. You know what I mean? You know what I'm saying? You got it. Of course you got it. You're the teacher. Anyway, so now I'm going to do it. I guess I'm just going to blow harder, about from the same spot. Ruler. Let's do this thing. This is about 2 inches. Oh. Did you see that? That literally collapsed. Look. I'm a genius. I was right. It collapsed. That was really cool though. Look. It's like folding down on itself like that. So I would say I was right. I blew harder and I could see that the tent collapsed even more. This confirms that increased airflow lowers the pressure even further. Okay, so overall, this experiment demonstrates Bernoulli's principle. As airspeed increases, pressure decreases. Basically what I just did. This directly relates to phonation, or how we produce voice. So when air from the lungs passes through the narrow space, little tunnel, between the vocal folds, it speeds up and the pressure drops. The low pressure pulls the vocal folds together and they start vibrating rapidly. This vibration is what creates the sound in our voice. So without the Bernoulli effect, our vocal folds wouldn't vibrate the way they do during speech. So thank you, and this is part 2 of my Phonation / Bernoulli Lab. Thank you.